start. So, hello everyone, and welcome to our webcast about AppSec and root cause remediation, unlocking the choke points to reduce risk. I am Liav Kaspi, co-founder and CTO of Legit Security, and with me is Justin. Do you want to introduce yourself?
Yes, thanks, Justin Bradley. I'm the VP of Customer Success and Support. So I'll be adding some context and some customer stories to the discussion in the demo today.
Cool. So, for those of you not familiar with Legit, we'll spend some time talking a little bit about the company before. But we're an ASPM platform, application security posture management. If you have coincidentally seen the Gartner report that came out on ASPM in January, root cause analysis or remediation is mentioned there as one activity that's becoming core for ASPMs. This specific webinar, we're going to deep dive into a little bit about what does it mean and what is root cause remediation. It's a little bit of a different take on that. And how do we see this becoming something that's crucial for effective application security? If you have a question during the demo, feel free to submit that in the questions. We'll try our best to answer that as we go. And if not, we'll leave some time at the end. Cool, let's start. So before moving, let's just talk a little bit about what's going on in the world. So the one thing I just want to share here is that more code and more software is now being created more than it has ever been. The reason is that developers and specifically engineering organizations have a lot more capabilities at their disposal, where they can basically create, spin off, and run application at crazy speed. There's services today that let you prompt your website and get it live in an hour. So building blocks like cloud, the ability to do continuous delivery, and AI are just a few, but there's a lot more frameworks and layers that allow engineering to move very, 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 very fast. With moving very fast come the problem of how do we make this secure? So when you have a huge environment changing runtime thousands of times every day, using AI in multiple areas, which now starting to be called the AI native times, what we see happening also from our customers and the people that we meet is that they undergo thousands of changes. They use AI in multiple places to generate code, to build their applications internally. They embed models in their applications for the benefit of their customers. And one way I like to think about it is that developers today they make a lot of decisions that they haven't made in the past. They have the power to configure cloud. They have the power to introduce third-party services, whether it's working with an SDK to an API or introducing an open source library. They have a lot of power to expand the attack surface of the organization. And organizations don't necessarily know this attack surface, and they don't necessarily have an idea of how can they actually secure against that. So if I'm introducing a third-party library, I'm introducing another third-party risk. If I'm introducing my application now sends communication email through a third-party service that I just created an account over the internet, I'm now sharing data with a third-party service. Who knows about that? The fact that engineering becomes that much empowered makes security so challenging. But I want to just take one step ahead and say, or the enterprises that we deal with and talk with on a regular basis, one of the biggest problems that they see from their side is there are a lot of capabilities today to detect these vulnerabilities. So they scan everything from APIs, code, open source, SCA, SAST, pen tests, but eventually they end up with an immense number of vulnerabilities. And I'll use that to of like move forward, I think this is where things like root cause analysis becomes to be critical. I'll just leave here a quote from Gartner that says that today there is this belief that the attack surface, the application threat landscape, is becoming more and more challenging. So there's more and more things coming, almost on a, I would say, monthly basis, new class of risk that now becomes a trendy problem that application security owners now need to protect against. Cool. Justin, let me know if jump in if there's anything.
Yeah, no, I think you nailed it. It's the concept of the problem is getting bigger, not smaller. That's as simple as it gets, and our customers are definitely telling us that as well.
Awesome. So the three major problems that we see that are kind of like holding back teams is, first of all, is they don't know what the risk of an application is. It's as simple as that. They build an app. App is a business concept. It's not one code line or it's not a website. It's a collection of multiple things that represent a service that a company creates or a delivery they make if they make something that's tangible. So what's the risk to my application is a question that it's very, very challenging to answer. You have to have a very clear view of all the data sources, bring them all together, normalize them, and be able to interpret them in the right way to be able to just answer what's the actual poster of that app. That's a huge challenge ASPM products like Legit is tackling. The second problem, once you know what your risk is, how do I take it down? So I have a million vulnerabilities. What's important here? And how do we take it down to a lower risk level? The third problem is that all of that process is continuous and inefficient. So collecting tickets and chasing them is something that people spend a lot of time in, and I love to think about it that every vulnerability that's a ticket, it's a unit of work. Somebody have to spend time, even if it's like the minute you need to triage and move it. So there are sometimes millions of potential units of work sitting in a Jira or on multiple tools, waiting for somebody to do them. If you add up the numbers, they don't make sense. Nobody's going to fix all of them. And they keep on adding. So how can you make this operation continuously efficient in a way that we want as little as possible new vulnerabilities, and we want to spend as little as possible time when we need to fix something? So these are like the three problems. We'd like to look at them as like find, fix, and prevent. Three categories. Prevent, the last one is not necessarily saying prevent, but eventually how can I protect against future risk? How can I stop the flow of new tickets in an automated way? So most of you working with security products would probably emphasize with the problem where you open a dashboard of a security product, and also Legit sometimes like suffers from the same problem at various screens. When you open up the main dashboard of the product, and what you see is you've got a million vulnerabilities and you've got thousands upon thousands of criticals. So this is something that's not uncommon to any product. It is a problem. There are some strategies, and everybody's trying to nail down what are the strategies. Okay, what next? We can't do anything with this number. And I'd like to say if something is critical, if everything is critical, there's definitely a problem. Because it couldn't be that I have 50,000 critical finding the house is on fire. I have to fix. I have to do 50,000 things to de-risk it. There has to be some catch here. Justin, what are from your experience talking to application security and customers, like what are some of the ways they try to handle these challenges?
Yeah, it's a great question. I think that first and foremost, these are not uncommon numbers, obviously of different magnitudes, depending on the size of the company and how many even scanners or systems they have out there. But the reality is these are unmanageable numbers. A million things, a million units of work is not something you can ever do. So the idea is what customers do is they get overwhelmed, and then they try to make the best decisions they can based on the facts that they know. And most times, most data points that they have are really simple buckets of criticality or severity. Hey, these are critical issues. I'm going to go after them. Then the question becomes, which are the criticals you need to do first? And that's where the real hard part comes in. There's so many missing pieces of context and data that most customers have when we start to work with them, that it's a matter of even just organizing the data they have or putting it into a context that they can understand what is the most impact I can have on my business. Because the reality is, no matter what that number is, you have more things to do than people to do them. It's the universal truth of all customers. So what our game is to help customers try to look at this problem and divide it up further and further and further, not only based on things that maybe we find, but also things that they know, business impact, business criticality of their applications. It's really hard. Everyone wants to get to inbox zero. It's just not a feasible thing in the way everybody does things today. If you do things one by one, you'll never have enough resources and problems. So the backlog is real. It's overwhelming, and I think it's a really interesting problem to try to dive into. By the way, a side note, when we get into the remediation piece, one of the most frustrating things of a customer is inefficiencies. So they might have 50,000 units of work, but when they go to the same file 7 times, that's frustrating because they could have done 7 things at once. It's a different discussion, but these are the problems that our customers face today.
Yeah. Cool. Thanks. So with that, I would like to introduce root cause analysis, root cause remediation, and talk a little bit about what does this mean. So when we do root cause analysis and we look into what it is we look at vulnerability and we analyze a couple of questions, actually 4 things that we're trying to analyze. First of all is what introduced it. So as you will see in some examples, it could be a vulnerability in something, let's say a runtime or a container, but it wasn't introduced by the container. Most likely there is a code line or configuration line that introduced it. So we have to find the actual place in the code where this vulnerability originates from. Will help us find owners, it will help us find a lot of information. And the second question basically is derived from that. Who and when? How long am I exposed to this thing? And can we find the person that owns it or the person that most likely know what should we do? So again, pinpoint the location can help us make the next question as where, who, or when. Third thing is, well, if I trace back to this root cause, if I found one data point of a vulnerability, find what introduced it, maybe this root cause actually introduces more things. Maybe there is more heat map to the risk. If I'm looking at the container, it's deployed. There is more risks that are derivatives of that same root cause. So can we find all the different risks together and connect all those tickets that represent a problem originating from the same place that actually affects maybe multiple products? Last point is why, which is it's a tricky question. Not everybody does that or go to just think. We see a lot of organizations stuck in this loop of, okay, we found a vulnerability, there's process. We'll open a ticket, we'll find the right person, we'll solve it. It's very easy to build a good process of vulnerability management and get stuck in it. But if you stop and think, why the hell this vulnerability was introduced? How is it possible that somebody just coded SQL injection? You can come up with preventive solutions. You can go back, and we'll talk about this a little bit at the end, and say, maybe there's a control failure, maybe an earlier test failed, and now this is a ticket. Or you could think about some automations or even an infrastructure that we can build for engineers that would prevent most of these situations. So almost like eradicating a complete class of vulnerabilities through an architectural change. So the last one is a question that I often, from my experience, Justin, I don't know if you have insight on that, I don't see a lot of people asking because they're sort of like stuck in this vulnerability management process that's very daily for a lot of people.
Yeah, exactly. It's a maturity thing, right? Like as companies mature, I think they simply come to the following conclusion, and every customer comes in a different path or a different amount of time. They come to the conclusion that I have too many things to solve. So either I prioritize them as best I can, and that's one method. But the additional method is maybe I can reduce that thing from even escaping because it's so much more efficient to never have to fix it. And the amount of time that they would save by doing that. So those are the two methodologies that we see from customers when they're thinking about the problem of root cause analysis. And generally speaking, if you think about the problem itself, there's more problems than people. That's always going to be the case in large or small organizations. So what's really interesting when we start to dig into it, I think the iceberg is a good analogy because or a good image because it really is something you don't really truly understand how complex it is until you start to dig into it. So for example, we see a lot of customers who say, great, I have a ticket, I assign a ticket to a developer, the developer fixes it. Easy, right? Well, it's not that simple. You have shared responsibility models of who owns what when you start to roll out things like Jenkins. You have the ability for different developers to have different pieces of the software factory. So they might be involved. Even a list of where people are in the organization, what they own, and who maintains that is super complicated. We see so many war stories and horror stories because we ask the simple question. Okay, you found a vulnerability. What do you do? Now you know you want to fix it. It's not a false positive. What do you do? And the answers we get from customers are really concerning because of how much effort, manual effort it takes. Things like, yeah, we get in a Slack group and then we ask someone and then they tell us and we negotiate the SLA. These are stories we hear all the time because there's no good way of doing it efficiently, at least up until this point.
Yeah, yeah, I agree, and I think it's when we have a little discussion on prevention at the end. I think you just emphasize how um, how costly is a ticket or a detected vulnerability after the fact. It's now owned by the security team, but they need to use the engineering team to fix. There's so many gaps in the way. Imagine if you could wave a magic wand and have very little amount of tickets, not just fix the current ones, but future wise, make them just be fixed as part of the process or even like secure by design development. Um, so I'll move into going into some examples. So here are some examples of illustrations depicting some stuff that legit is also working and doing. Like, how do we identify root cause? So the first example here is the simple one. We've got something in the cloud that goes back to the code. So if we run a cloud security tool, it looks at containers or runtime. It will have findings on these same containers. But as you look at those findings, they could come from like one vulnerable dependency. So in the example here, I have one vulnerable dependency that makes its way into a container. It's now duplicated 320 times. So I will have 320 findings across different runtime microservices, all coming from just one dependency that has to be addressed, either fixed or deleted or replaced. So that's one example. The other one is same concept. We found a code finding that is actually manifests itself in an API issue, or a web app. So either a pen test on an API security product has found a problem in the live API of this application, looking at traffic, which just goes back into a code finding. It's very tricky to find. It's not an easy correlation to do. There's no products today that can 100% guarantee we can correlate one-to-one all of these findings, but when you can correlate them, it's very, very useful. You go back to the code line, you know who introduced it, you get all the benefits that we discussed before.
Can you go back one? Sorry.
Yeah,
One kind of story that I hear a lot is it's a passing the buck, right? If you don't have a mapping like this and it's not well laid out and you don't have this root cause, what actually ends up happening is the idea behind the business impact. So meaning what usually happens is these vulnerabilities, these findings become tickets. Those tickets become SLAs. SLAs have timeframes on them depending on the organization. So what actually happens is if you without a mapping, people are passing the buck. So you go to the one team and say, "Hey, I have this finding, I need it fixed." They go, "Oh, that didn't come from me. That came from the container registry, or that came from the hub, the environment before it." So as you start to see these things materialize, what ends up happening is people are starting to push it down and down because they don't have complete visibility of where it actually came from, and no one can actually tell them, which is super frustrating because it's on a ticking clock. It's not like you have unlimited time to fix this. So it's even more complicated than just doing it in a vacuum. It's you're putting business impact and people's performance on the line as well.
Yeah, yeah. And it's an awesome example. And it's very likely the case in many places that there is a shared library that one team develops. But then when the library is the cause for the vulnerability, let's say detected on an API, again, you're blaming the wrong team. And nobody in the team that actually owns the application knows, hey, where is this coming from? We don't own that code. So you layer up modules. These are real struggles and problems that only the correlation, only if you could correlate all those different data points, you can start have the information that helps you solve that. The second problem I want to discuss, which is the problem about dependencies. Open source dependencies create a massive load of tickets and vulnerabilities. Massive. I even remember the first time years ago when we ran container scanners, when containers started to be popular, and we ran container scanners on our containers, we had like a 200 findings on the official Linux version. And we were all surprised, like, first of all, why does the official Linux version has 200 vulnerabilities? And second is, why is this number so high? There is a lot of complexities in vulnerabilities. They open source vulnerabilities are libraries you're using. They are dependent on other libraries. There's a dependency tree. Depending on the ecosystem, if you're working with an ecosystem like Node or JavaScript, you might end up in thousands of dependencies in a single project. And if you import a huge framework like React, you'll end up with a tree of 200 or even hundreds of nested libraries. So the nested libraries are out of your control, but they might have vulnerabilities. So when a ticket comes in, it's the same problem. You see a vulnerability in a library that you don't really have control over. And basically what happens is that there are some dependencies or some container images, same problem, that are responsible for bringing in a very large number of vulnerabilities just by introducing them. By the way, it's also something that gets worse with time. So as new CVs are disclosed, you might have a very clean project, but then you wait a year and then there's 30 new vulnerabilities as part of that project. So you don't really need to change the code to start becoming vulnerable to known open source vulnerabilities. What's frustrating about this is that these problems that we shown before are stacked. So you get this dependency tree that's coming from one, let's say, dependency, and now this entire tree is being copied all across your different assets. So I gave here an extreme example, which also includes duplicates, because there are duplicates almost everywhere. So you got two scanners reporting duplicative trees, each with 26 vulnerabilities. They all come from the same library. Then you've got another scanner that scans your containers, which finds 18 vulnerable images. Again, all of them share the same 26 vulns. And then you have all these runtime. So you can do, I did the math. You can double check me if you want. This constellation will report in 2,600 issues. So you have 2,600 vulnerabilities. You remember the 50,000. All of this is coming from just one library that somebody introduced, could have been clean, is now reporting 2,600 findings across all the tools. Could all be critical in this respect. And then this is a would be very useful to know that all of them originate from that vulnerability. So if you come across one of them, let's say one of them, usually that's the case. Usually you would stumble upon one of them, and as a security engineer or developer would want to fix it, but you would want the information that it goes back into this specific dependency, which has a lot more context to add.
I think one of the things that very small analogy that we hear from, or story we hear from customers, is the shifting left concept has been around. It makes sense. People have been trying to do this. The problem is, without a map, you can't measure it, and you can't have a specific ROI or impact of how many issues that it correlates to. If you don't have one, you can't have the other. So people are saying, yeah, let's fix our dependencies and let's make sure they were doing things as left as possible. There's no real way of measuring what that impact is downstream. So having this becomes the output of why it's so important. Not just that you should do it, but what is the actual impact?
Cool. So with that, giving these examples, I want to talk about root cause remediation. What is it? Let's use the information we have on root cause analysis to drive remediation. So if we identify, let's assume for a second we've got this magic power that can help us do root cause analysis, help us connect all the dots together. I want to talk about 4 different cases or 4 benefits that this information has. And hopefully you'll get out of this webinar understanding that this is a really must-have capability that has to be everywhere, and you have to maximize the information you have on root causes. One is risk ranking. Second is identifying owners. Third is next best action. What is the biggest thing I can do? And fourth is let's extinguish, let's fix big chunks of vulnerabilities instead of doing it one by one. I'll spend a little bit of time over some of them. The first one, I want to talk about risk ranking, which is a very, very trendy and popular topic right now in AppSec. Basically saying, can we quantify the risk of a vulnerability in a smart way that helps us understand what should we do with it? Curious, Justin, how do you see this today? How are enterprises tackling this specific thing?
Yeah, a couple things. First and foremost, the best way to say this is just a number. It's a legit number that every vendor has some sort of risk scoring or risk ranking. So they feel proud that their number is the number. But if you don't know what that number is made of, it doesn't mean anything, right? You have to understand fully not only where the information is coming from and how it's weighted, but even having control around what that number is and having manipulations, because the magic formula of all risk ranking for our customers isn't just can legit find the most actionable, most specific risk based on things I can discover, that it's exploitable to the internet, that you can exploit the vulnerability, that it's visible to the internet. All of these things can be discovered. What we don't know is what does this application do? Like, what is the impact of this application of the business? The real magic, in my opinion, of real risk ranking and scoring is the combination of things that are discovered and things that are told to us. And together that creates the complete story of really being an actionable number and something that means to the customer. A quick story that in a former life, when we used to go in and say, okay, you have all these problems, what do you want us to do? That's a very different conversation than what is the thing you can't lose? What's the most important thing in this environment? Or we used to say, what is the resume generating event that happens in this environment? And the customer will say that yeah, if we lose this app, we're all out of business. Cool. Let's make that one more of a priority, even if the actual siloed risk is the same of that application versus another. That one's more important. That's where customers are starting to see we can detect data and provide all this rich information, but you have to marry those things together with what's the actual business impact. It's critical.
Yeah. Well said, and I think that the connection between that and to root cause remediation is the ability to bring the context from what the finding is. So if we're looking at a finding on a code level, or even better, a finding on runtime, we have some information about it. We know like what this, is it internet facing or not? We have some runtime information. Well, if we can trace it back to the code and get some understanding of, okay, we know that this is this code component. We now know about the application. We know what the code does because we actually analyzed it, and we know the code is handling sensitive data, or the code itself is reaching out to third parties. So there is a code flow that goes from the vulnerability into a third party service. So there is context that we can know only if we could trace and connect the vulnerability back where it originated from. We could add information about the build system itself. Is it vulnerable? Maybe the build system itself has some problems, and we know that this actual vulnerability hasn't gone through the right process. We're breaking compliance. There is a lot of context we can bring from correlating different components and understanding the full picture of where did the problem start, where it ended. So getting this full parameters and being able to quantify credit risk score is something that eventually, if you trust it, can help you narrow your gaze. And again, we talked about large quantities of vulnerabilities. An example down here in the slide shows getting from a huge number, 30,000, again, unusable number, into just 12 things that I'm convinced that I want to solve right now. I actually showed the formula. We didn't even score here. We just said, let's look at 3 things. Things that we know are exploitable, things that have actual internet facing, and things that I know have direct impact on sensitive data. I have 12 things. It's very simple to communicate. Nobody would argue that these 3 things together are bad, and just 12 items. It's not a crazy number, and it's a very easy way to understand what to fix. To understand actually what is falling into each of these buckets, you need the root cause analysis. Second example is finding what we call here best fix location. So I have a vulnerability. I go to the root cause. Where should I fix it? Who's the owner of this application? Who is the code owner? Who introduced the code line? I need all of these identities to understand what's my next step is. Where should it be fixed? How hard it is? Is there a code freeze? What's the situation about this project? Being able to point to that location is critical. Well, I think we talked about this just a few slides ago. And that's the second benefit of being able to pinpoint back where is this vulnerability coming from. Third benefit, call it here best bang for buck, but how can you look at the data and say, what's the next action I should do? What's the next thing? Obviously, you can risk rank, but you still end up with an individual problem. If you could look at groups of problems, if you could group together and say, here is an action that I can take. We can analyze the complexity of that action, how easy or hard it is going to be to carry this action. We can analyze the impact of that action, but here is one action, here's one root cause I'm going to fix, and it's affected, its positive effect on my risk score. And actually, I have here like a hypothetical example of distributing these across, different axes just to identify these pockets of where there is opportunities for. Here is a task that actually has huge impact on number of applications, fixes a lot of risk, and very easy. Sort of like finding this magic quadrant of low-hanging fruits, which are very, 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 very beneficial to the organization. They're also very easy to carry. They probably are not going to break anything. This is, just when you mentioned it, there is a lot about here about motivating and incentivizing the organization to take action. This is a great evidence of saying here is a 0 to hero opportunity.
Yeah, and just to add a little bit, by the way, if you guys have questions, drop them in the channel. We can either take them offline or answer them live. But I would say the one-to-many multiplier, the force multiplier you're describing is right. I can tell you for certain is a game changer for customers, because really, if you think what's happening, it's doing something. So the old way, like you said, one work of unit at a time, customers would be very happy to only get through their critical and highs. They kind of measure their success based on only those 2 categories, which is sad because the reality is they've come to the conclusion that's all they can actually do, What actually ends up happening is you're still focusing on critical and highs as your top priority, but by chipping down those issues behind the scenes, you're actually knocking off medium and lows. And you're seeing customers say, oh my God, like not only did I reduce my risk in a measurable way, I'm actually burning down the list of things I thought I was never going to get to because I don't have to do extra work to do that. That's the whole point. And it's really a different way of thinking about it, less siloed and more one-to-many. And it's really the impact of issue reduction is off the charts. We're really happy like what we're seeing from our customer base.
Cool. So the last one I want to talk about is like this bulk remediation. I'm actually giving here an example that's more along the lines of just cleaner reporting. So in this example, we have 170K-ish of issues that are now just grouped by the root cause. So I group them by vulnerable parent dependency, container images, code file or modules that all share the same vulnerability. So I group them together. If you get an XSS in a 3 or 4 location in the same kind of like JavaScript module, you might as well sweep them all together. Vulnerable build scripts, vulnerable API endpoints. So violated organizational policies, etc. So each item counts actionable root causes. And then eventually, if you do this in bulk, if you start looking at it this way, this is a cleaner way of doing this. And this is an easier way of saying, okay, now I can go in bulk and say, okay, let's fix everything in this API. And it's a different way of looking at the data, but might be a cleaner and more, I would say, just easier way, digestible and actionable way of understanding tasks. Here is a sample from a new capability on Legit that is now being rolled out. We'll do a quick demo right after that. Here's, for example, an analysis of a root cause from a dependency that introduces other dependent issues. Eventually, you can go and see information like what does it impact? It's actually coming from multiple source tools. So there is another dimension here for deduplication. So there could be multiple source tools that report on vulnerabilities of this specific root cause. You can see which one is this. In this case, it's a library called Pillow. It brings 12 criticals all together, either by itself or its dependents. And you actually have the link to the external place. And as I'll show you in a couple of minutes, remediation guidance that is going to help you actually just, or your developer, go directly to where you need to fix that. Legit is also bringing information from the application itself where this resides on. So for example, I can tell which compliance frameworks are required and this thing is part of, and I actually need to fix this because I need to be compliant with these specific frameworks, etc. So again, this is Legit Security has, and I'll move here to a quick demo, is now rolling out this, I would say, first version of our root cause remediation or actions capability. I see some question on that in the chat. So that's a capability rolling out. If you're a Legit customer and you're interested, we will let you see this and open it up for you as soon as possible and can give you some dedicated session on how to use that. So welcome to Legit Security. I will spend 2 minutes just to demonstrate that. But here I have a large environment consisting of multiple findings coming from multiple scanning tools, all aggregated together, constituting a large number of vulnerabilities. Looking at my heat map, I can see that my infrastructure project actually has a secret problem and an SEA problem that's actually taking a lot of my risk. But instead of going into my issues view, I actually want to go into my actions view. So I'm actually as you can see, we had 4,000 vulnerabilities, but Legit has registered only 300 actions, meaning that there's to fix my risk here. And I haven't yet filtered this on a specific application. I can actually go to my infrastructure app. There is only 300 steps that I can do to actually go and fix it. Legit has already ordered them by what is our best recommendation of what should be fixed based on some metric that we calculate, like what's the total risk that this thing is introducing to your organization. But if I pick on a specific one, I can show you here a couple of grouping logics that Legit is using to group them together. And here's the example that I shared before. Here's this pillow example on a specific repository. If I actually go to my remediation, I can see here's the manifest file. I can link directly to it. Here the version where it's fixed. What's actually more cool about this is that this thing is actually part of 56 different issues. So there's 56 vulnerabilities, all coming from a tool. In this case, it could be SemGrep or Dependabot. There are 56 registered findings for that specific vulnerability. Legit has the option to actually ticket this. So I can go and create a new Jira ticket, which will now include information of all the CVs and will tell the developer, go and fix that. Here is the fixed location. Here is the link to the repository. Here's all the CVs that are now part of that vulnerability. So if you a legit user and you come across one of those specific findings and you create this bulk ticket, you will see that this already has been ticketed as part of an action. So Legit also supports the other way around. So and as you look at an issue, we will tell you this issue is actually linked to an action. Besides dependencies, we also do a couple of other grouping logics, and the number of grouping logics in Legit is actually rapidly expanding with our intention to also allow custom groupings. So first is like pipeline file. So a pipeline misconfiguration file, a GitHub workflow, using multiple external mutable images. You can just directly go to the file and fix all of them in one go. This is a one workflow module owned by a DevOps team. In most cases, based on our conversation with teams, there is probably one person that can go and fix that file. Another grouping logic is secrets. Secret value that has been exposed in multiple locations, in this case, like a password in a URL, could be in multiple code repositories, Jira tickets, Confluence pages. So there is a lot of, it's the same revocation or rotation that needs to be done. But
One thing, another kind of byproduct that we're seeing, which I find very interesting, is the trust that's being built up in between the security team and the development teams based on this information. So when people start to group Jira tickets or group issues into Jira tickets, I should say, or reduce the sheer number of tickets being out there, the reality is most of the security people we work with, especially if your program is relatively new, they don't have the development background and experience to collect all this data. So they're very reliant on what Legit tells them. But going and taking this piece of data to a developer and saying, everything's important, but this is why this is worth your time because it knocks out the most amount of risk in multiple ways, you're really saving that person time to not have to do 10, 50, 100 things. And it becomes a strong building environment, environment between the two parties, right? They're no longer going and saying, I hope this isn't a false positive. Now it's, I know this isn't a false positive. And if you do this, you'll solve many issues. We're reducing the risk together in an efficient way. You're really sensitive to the developer's time. And that I can't tell you how much developers appreciate that because they've had this list of issues on their plate for a long time. It's not like they don't know about them. They just never had the time to do them. So this is game changing from both sides of the fence, in my opinion.
Awesome. Now with things that Legit has, you could go and look for other action types. Like for example, we group together infrastructure as code files, pipeline file, secret value, even misconfigurations. So one of the whole thing is that you might have multiple projects that are sharing the same misconfiguration, like a branch protection thing. is actually fixable by a parent config. So you can go and ultimately flick a switch and fix all of these things in um, one global action. So again, another grouping logic that Legit had. There is a way to, with the powerful Legit query, to go and filter your action based on a lot of the exploitability things. So for example, we can look for actions applied on, let's say, code repositories, which their information about their legit context is, for example, handling sensitive data. So now I just want to fix the problems in my application that handle sensitive data or expose API or internet facing, use AI, etc. So I have only 48 actions that actually talk about this specific business critical or specific category of projects. So our powerful query, which takes all your SDLC context, is actually available to filter down what you want to do, and then eventually go and select the one that you want to fire away, prioritize, and fix. And eventually, this is going to fix large percentages of your organizational risk. So we're getting close to the end. I'll just wrap up, and then if there's more questions, feel free to drop them in the box. Some things that are interesting for us to take a look at, and some areas where Legit is looking into, is how do we find organizational level root causes, which is a little bit of a different topic. I'll just mention here this slightly. This is an area that's been our focus and still our focus for this year, which we feel like is going to make a lot of products and features in our platform, which could have tremendous impact. So things like being able to identify which type of vulnerability is the most common, or can we find continuously vulnerable asset, things that are responsible not just for all this risk, but for continuously bringing more risk. Who are the top risk contributors? Can we leverage some smart insights into being able to pinpoint some specific area that is responsible for introducing a lot of vulnerabilities? There is a lot of opportunities today also with AI to analyze these things, and you might expect a lot of things coming from Legit in the closed time frame that are going to tackle these specific areas. One thing that I just want to mention about prevention, and we said we'll spend a couple of minutes about this at the end. We started with find, fix, and prevent, and 3 challenges. We mainly talked about fixing. Preventing is something that, from at least from the experience that I have, talking to a lot of organizations and AppSec teams and security professionals, this is sometimes the mindset that people, I want to say, forget or get carried away and don't think this way. Obviously, they would like to have more and more and more guardrails and more, shift left controls, but it's not the only option. There's 4 steps that we identified that all can help eventually the ticket not to be a problem of the security team. We could alert, and think about it, it's like if alerting about a problem gets to the developer, if you got root cause, if you know who introduced the problem, and you alert them, there is a chance they're going to fix it. There is a chance that they say it's still fresh in their mind. They said, "Oh, I introduced this. It's a problem. I'll spend another 10 minutes to fix it," instead of going back later. If you automate a ticket, this is something that would eventually not require the team or a security team to actually do anything. If you can automate the delivery of the finding to the team, or even automated remediation, this is going to be something that's actually going to save you all those times chasing people. Preventing is about placing those guardrails, placing those CI/CD guardrails um, into the pipeline in order to block new vulnerabilities. And then the last piece, I want to call like architect, is how can we build tools so developers cannot introduce new vulnerabilities, or at least have a very hard time. Could be like a golden image, could be a package firewall. There's some discussions about it, like you can't pull a vulnerable package. It could be a vault that everybody has to use, and they are encouraged to use instead of using secret. So what tools could you bring? This is magic. If you can go down to architecture level and be able to architect a pipeline that's resilient, it's awesome. It's a lot of work, it's development, but it's still something that can go a long way and save you thousands of future potential items. My point going over these items, none of them is possible if you don't have root cause analysis. You can't really find a developer. You can't really understand where and what to prevent. What's the things that introduce all the risk if you don't do that. So I hope by now, if you haven't been, you're more convinced that the ability to do root cause, the ability to get this information out from findings is critical. Take a quick look at a question as well.
Can I add
Before
one
I
thing as
move
well?
on, yeah, Justin, I wanted to ask.
Yeah.
Yeah.
No, I'll just jump in. So one of the things, this is a really common problem because it's more complex. Obviously, in a POV or in a demo, it seems simple, right? But you're talking with people, and people have emotions and work to do, and it's just a very complicated thing. So what we see when we start working with customers originally is this big, the most common thing we hear is somebody saying something like, "We know we have all these problems. Thank you for helping us organize them and make them prioritized. I can't get anybody to do anything." Like literally, that's what people say. So by pulling out root cause and starting down that path of find, fix, prevent, and even architect, what we're seeing is customers starting to create this phased approach, this journey. And it's never overnight, right? Obviously, prevent is a very scary concept, but when it's very granular, when it's very customizable, when it's very flexible, you get early adopters to make progress. And because we're scoring and ranking everything in a way that the customers choose, then they can either have the carrot or the stick, right? Everyone thinks that it's preventative is a stick, but it's really a carrot. The idea is you're starting to almost gamify how your security team, how your development teams are having security posture. And it becomes a game where, believe it or not, development teams do want to not be the worst one in the team or the most behind. All of these things are the supportive details needed behind actually improving. And the last thing I'll say is, once someone is now in the mindset of that they have to find and fix things, preventing is actually embraced because they know it's faster. Because the thing that they've come to the conclusion of is they have to fix it, versus the old days of I'm going to try to talk my way out of doing this. Once you get through that gate, then you need prevent to be more efficient and force multiply. That's the best way I can say it, but it changes the dynamic of security teams being frustrated because developers won't do anything to this cohesive approach of how everyone is on the same page and they're doing things as fast as possible. That's really the ultimate state.
Awesome. So I see we got a few questions in the chat that address like I guess from legit customers that want to understand more about a feature. I would say we'll privately demo, open, and guide all of you through that. Don't worry. And thanks. Would love to see that legit customers are jumping on our session. So thank you very much for attending. I'll wrap up this session quickly. There are a lot of software vulnerabilities. A lot of them are correlated. Basically, I would say there's a lot of products today that can help you collect tickets, but what you need is to connect them. How is this thing helping? prioritization. We talked about this. We talked about finding fixed location. We talked about finding what's the best bang, what's the next step you need to do, and about like doing some bulk actions or extinguishing. So last point we made here, that prevention is tied to that. If you know why something was introduced and where, then you can go and then architect your solution into preventing more risk. That's as simple as it gets. I hope that was insightful. If you don't know about legit, then you'll probably be happy to know that we're an application security posture management platform. ASPM products are new and emerging category. Gartner predicts 80% of organizations that develop software will need them. So this becomes a standard thing for running an effective AppSec program and delivering application free of vulnerabilities. Basically, the three main use cases that legit security itself is catering for our customers is this application vulnerability management that comes with ability to prioritize, to correlate, and you've seen a glimpse of that today with the new actions components that I've demonstrated quickly. The other piece is being able to secure your software factory. So discover all your assets, build this application inventory, understand the posture of your tool set and of your code, protect your pipelines, and ensure they're compliant. There is a lot of things that we can analyze on the tools that build up your software, not just, I would say, call it like on the kitchen itself and not just the food that it produces. And lastly, we are, as part of securing this environment of CI/CD, we're securing this massive problem of secrets, which are virtually everywhere. We analyze where secrets are and help you reduce the risk coming from sensitive data sprawling into that environment. Legit is running on deep analysis of pipelines and code to drive context and help you prioritize. If you want to learn more, you can reach us out on our website directly on the emails you receive these invitations. So feel free to request a demo, and hopefully looking forward to see you again in other webinars or in customer meetings. And thank you all for joining.
Thank you.